Hi there. Today we're looking at finding values of normal distributions. And really what we're doing here is the reverse of what we've been doing. What we've been doing is we've been saying, hey, what's the percent or the probability less than or greater than this value? We would convert that value to a z-score. Then we would look that z-score up on our z-chart, and then we'd identify the percent or probability from there. Today what we're doing is we're kind of going backwards through the process. I'm going to say, hey, what value represents the 50th percentile? Well, then I would look for the thing that has 50% of the values below it. I would find 50% on the z chart, find the z-score that goes with that, and then translate that back into a value. Okay, so finding z-scores based on a percent, the percent. So find the percent or the approximate percent within the z-chart, and then determine the score associated with that percent. Again, we're just doing exactly what we've been doing, but backward. Instead of looking up the z-score and then finding the percent, we're hunting down that percent within our z-chart and then seeing what the z-score is that goes with that. Okay. Once we have the z-score that goes with that, then eventually we'll translate that back into a value. For example, if we look at something like this, it says find the z-score for each percent. So it says the percent of values below the score is 82.64. So I'm going to go over to my z-chart. Let me pull up my z-chart here. So here's my z-chart. I'm looking for 82.64. And again, I just kind of scroll through here looking. When you look on the negative side of things, the highest the value that we get to down here is 50%. That's the biggest it goes, okay? So we know because it's above 50%, we're looking at the positive end of this thing. And again, I'm looking for 82.64, so I scroll around and I can kind of see it floating around right here. So I find that percent within this, and then I say, okay, the z-score associated that would be a 0.94. Okay, and so that's what I'm doing. I'm just working backwards for what I did before. Earlier, I would have been looking at the z-score and then finding the percent. Now I'm hunting down the percent and saying, okay, the z-score that goes with it is 0.94. So to answer this question, the z-score I was looking for was the z-score of 0.94. Okay, that was the one that had that percent of values to the left of it. Okay, below the score. For this one, the percent of values, the percent of values below the score is 7.78. So once again, I'm going to go to my z-chart. I'm going to hunt down that 7.78% and see the z-score that goes with it. So 7.78%, that's under 50%, so I know I'm looking at the negative end. And so right here, I see the 7.78, looks like it's right here. So that is a score of negative 1.42. When I look at the next one, it says the percent of values above the score is 38.83. And so here's the thing, before I run over to my Z chart here, because this is above the score, remember the Z chart gives me the percentages below the score, so I need to kind of convert this. I would say, okay, well, if above the score is 34.83, I'm going to have to subtract that from 100, okay? 100 minus that will give me the number of data values below the score. And again, that's the way the Z chart is designed. It's showing all the values below that score. So I need to, when I go searching for this thing, be talking about the values below the score. So if you plug this into your calculator, 65.17, okay? So basically, we've translated this now. I'm looking for the z-score that has 65.17% below the score now, okay? I've converted to that below value, and now I'm going to go over my z-chart. So 65.17, that's going to be on the positive end of things because it's above 50%. And I just search for this value. Looks like it's right here, 62.17, and that is a value of 0.31. Okay. If I look at the next one, same kind of thing. The percent of values above the score is 94.4. We need to translate that into, okay, well, what percent is below that score? So if above the score is 94.4, below the score is going to be 100 minus that, which is a 5.6. Okay, so the percent of data values below the score now is 5.6. That's what I'm looking for on my Z-chart. So 5.6 is below the 50% mark, so I know I'm looking at the negative end. So it looks like 5.6 is pretty close to this value right here. This one is 5.59. But again, we're going to estimate this. We'll round it off a little bit. So that is associated with the value of negative 1.59, it looks like. Okay. Oh, look at the next one, same kind of thing. Approximate the z-scores that contain the middle value, the middle 60% of the data. So this time we're working our way out from this thing. And again, if it helps, let's think about this in terms of the normal distribution curve. If I look at the middle 60% of the data, in other words, as I kind of work my way out, I want 60% from the center, which means kind of 30% in each direction. And again, the whole goal of this is to kind of translate this into basically scores below the data value. So if this is 30% and this is also 30%, well, now when you kind of think about this, that means at the middle of this thing is 50%. So that means this chunk right here would be 20%. So the first data value associated right here with this z-score should have 20% of the data below it. When we look at this guy, this z-score right here should have 50 plus the 30, so 80% of the data below it. Okay, so I could look each of those up on the Z chart. Really, I only need one of them, and then I can use that idea of symmetry to find the other. So if I find this first Z score that has 20% below it, let me find that on the Z chart. So 20%, I know I'm looking at the negative end here. So I hunt down the value of 20%. And again, I might have to round this a little bit. It looks like the closest one I have is probably this one right here at 20.05%. And the z-score associated with that is negative 0.84. Okay, so negative 0.84. So if that first z-score that marks kind of the lower end of this is negative 0.84, it means that upper boundary is automatically going to be positive 0.84. Okay. And again, that upper value has 80% of data values below it. When I look at this thing from here on down is 80%. So I could find that at the Z chart and it would confirm that. But again, this idea of symmetry, don't work harder than we have to. Once I found one, I find the other automatically. Okay. So now we're going to take this a step further. I'm going to find values based on that percent. So once again, I'm going to identify the z-score associated with the percent, and then I'm simply going to convert that z-score to a value on the normal distribution. Okay. To convert this thing, here's the little conversion formula that I'm going to give you. Basically, this is the z-score, so that is the z-score itself. S is the standard deviation. And then this guy, the x with the bar over it, of course, is the mean. Okay. And so we do the z-score times the standard deviation plus the mean. That'll convert that z-score back to a value in the normal distribution that we're talking about. Okay. We could also basically use the z-score formula, data value minus the mean divided by the standard deviation, and we could plug in what we know and then solve that for the missing value. Okay. And we've done that in the past, but I think most of us found just using kind of this little formula is a little bit easier. For example, if I look at something like this guy, it says the scores for an exam are normally distributed with a mean of 75 and a standard deviation of 6. It says what score marks the approximate bottom 25% of the class. So if we're talking about the bottom 25% of the class, we're looking for the value that has 25% of the data below it. So I go to my Z chart and I find the Z score associated with that. So on my Z chart here, again, 25%, we know it's going to be in the bottom half of this thing. And when I look for it, it's kind of right around these values, okay? And so really the 0.2514, the 25.14% is a little bit closer. So I'd probably go with the negative 0.67 for my z-score. Really, it's almost right in between these two z-scores where we'd find that. So if you wanted to do something like negative 0.675, that would be okay. We don't want to go too extreme with trying to get too accurate with this thing. We want to be general. So don't go any more than maybe a 0.5 in between, or just simply round it to one of those values, okay? So this one, I'm just going to do the negative 0.67. I'm just going to round it to that lower extreme, the one that's a little bit closer to, okay? So negative 0.67. So there's my z-score. If I want to convert that, that means I want to be negative 0.67 standard deviations below the mean. So I find negative 0.67 of a standard deviation, which means I multiply, and then I add that to the mean, which will take me negative 0.67 standard deviations below the mean. Okay, and again, that's where that little formula comes from. Again, this is a job for my calculator. I'm just going to plug it in, and I get a 70. 0.98. I'll just round it to about 71%. Okay. So 71%, that, or really just 71, it doesn't tell me necessarily that's a percent. It could be a point score. Okay. But 71 is the data value that marks the lowest 25%. So anybody who had a 71 or lower is in the bottom 25% of the class. Okay. Again, we could use the z-score formula, which says this. It's the data value minus the mean divided by the standard deviation. And we want that to yield a z-score of negative 0.67. Okay. And then if you cross multiply and solve, what you end up getting when you solve this is x equals 71. Okay. You get the same thing. I think most students prefer the little formula. That's all. If I look at this one, it says what score marks the approximate top 10% of the class. So again, if I'm looking for the top 10%, we have to think of this as, well, how many values are below the top 10%? So you would subtract, and that means there are 90% of the data values below the value that I'm looking for. So top 10% has 90% below it, and that's what I want to go look up on my Z-chart. So again, because I'm above the 50%, I'm looking in the second half of the data here. So I hunt down that 90% mark. And again, I'm going to round this thing off. It looks like the closest value I have is this one right here. That's the closest to the 90%. Notice the one next to it, 90.15%. That's still not as close as 89.97%. So I'm going to just go to the closest value to 90. And it looks like that's associated with a 1.28 as my z-score. So again, z equals 1.28 for that value. And now to convert that to an actual value on this normal distribution, I say, well, okay, I want to be 1.28 standard deviations above the mean. So I find 1.28 of a standard deviation. And then I add that to the mean, which was 75 this time. Okay. Again, this is a job for my calculator. I'm just going to plug it in. Looks like I get an 82.68. So approximately an 83%, or maybe we'll go a little more accurate with this one. I'll say 82.7. Okay. Again, that marks the top 10%. In other words, 82.7 is the lowest score you could get to be in the top 10%. Anyone who's above an 82.7 is in the top 10% of the class. Okay. When I look at this one, it says what scores would contain the approximate middle 40% of the class. And again, these middle ones are just a little bit tricky. We have to kind of think about this normal distribution curve, which that was terrible. I can do better than that. Okay, so the middle 40%, again, if I'm looking at the middle 40%, that essentially means that I want to go 20% in each direction. Okay, so when I look at this, 20% in each direction, well, that's just going to give me that 40%. Okay, but again, I want to think about this in terms of values below. I'm going to hunt down this z-score right here. And again, this other z-score, this upper end will just be a reflection of that. See, this guy over here will give me the negative version of that z-score, and then this one over here will just be the positive version of that z-score. So really, I only need to find one of them, and I'll automatically have the other. So now when I think about this negative z-score, the one on this end, well, if right here is 50%, and this chunk here is 20%, it means that below that score represents 30% of the data, okay? So 30% of the data is below that score. That's what I'm looking for on my z-chart, is that 30% and finding the z-score that goes with it. So 30%, I'm looking at the bottom half of the data, these negative z-scores, and we already knew we were looking for a negative z-score. So I hunt down the one that's closest to 30%, and it looks like we've got it right here. It's kind of caught between these two values. But again, we can see it's a little bit closer to this first one. 30.15% is closer than 29.81%. And again, it's somewhere in the middle of those two. If you want to say something like, hey, this is associated with, this is a negative 0.52. And then the other one that is closest to is the negative 0.53. We could go somewhere in between and say like negative 0.525 or something like that and go halfway in between those two. Okay, that would be slightly more accurate. But again, this whole thing is somewhat estimated to begin with, so it's not going to cause a huge difference if we add that 0.5 or not. So I'm just going to stick with the negative 0.52 for this one. And so if that lower end is a negative 0.52, it means the upper end must be at positive 0.52 because of the nature of symmetry here, okay? And again, I can convert each of these. When I convert this guy, I do negative 0.52 times the standard deviation plus the mean. And likewise here, I'm going to do 0.52 times the standard deviation plus the mean, okay? And again, this is a job for my calculator to find this upper end and lower end. So when I do the upper end, I don't know why I punched that one in first, I get 78.12. And when I do the lower end, I get a 71.88. Okay? And so that just means that the middle 40% of the class goes from about 72%, 72 as a score of 72 to a score of 78. Okay, so that represents that kind of middle 40% of the class. Okay, so again, we're finding the percent, we're hunting that down on our z-chart, we're finding the z-score associated with that, and then if need be, we convert that z-score to a value on our normal distribution curve. Okay.